This is Troy again. We've got one more little video here that we want to help you with, and this is making sure that as you're working problems, as you're encountering some of the schematic diagrams that you're going to be working with, that you're able to get the information you need and see how to put those into a formula, again, working with the calculator. Because generally you're not going to be taking these things, figuring them out by hand, figuring out where the decimal goes. What we want to do is be able to make sure that we can get the information into the formula, into the calculator, and get the result that we need out of that. The first example that I have here is simply using Ohm's law. What we are given is a 60 volt input. We have resistance of 12 kilo ohms, and what we're looking for is the current. How many amps is running through this circuit? We know that using Ohm's law that the current is equal to the voltage divided by the resistance. And so that is the formula that we're going to be using. What we need to do to be able to find that current is simply insert our values here. Now, this is a fairly straightforward problem. The reason that we want to look at it real briefly here is to make sure that on that resistance of 12 kilo ohms, that you understand you can take that straight to the calculator exactly like that. We know how to enter the kilo into the calculator at this point. So what I need to do here is I need to take my 60 volts and I need to divide by 12 kilo ohms. And that kilo means EE to the third power. That's what the kilo represents. The kilo is the same as times 10 to the third power. So when I hit enter on this, what I'm going to get is 5, and the calculator is giving me a -3 exponent there, which I know tells me that this is measured in milliamps. So as I'm looking at this diagram, I can expand this out and say 12 kilo ohms is the same as 12,000 ohms. I can put that in, but all I have to do is make sure that I'm using the right values and the right place for my formula, and the calculator is going to be able to do the rest of the work for me. That's really handy. One of the nice things about these calculators and the fact that they can work so efficiently in the engineering notation that I'm needing to use. There's one other thing that we want to be very, very careful with on the calculator, though. And this goes back to some examples that we did where we were looking at taking square roots, and sometimes it doesn't show us parentheses, but we want to make sure that we use them. And this is an example that is very good at illustrating why that's going to be true. Let's look at this circuit right here for just a moment. What we're looking for is the total inductance. It's over here as the L sub T, is what we're trying to figure out what value it has. What we do know is that here we have an inductance of 50 millihenries. Here we have an inductance of 200 millihenries, and on this part of the circuit we have an inductance of 40 millihenries. We need to figure out how we're going to put these together to get the total inductance that's being created throughout this circuit. We know that the formula says the total inductance is going to be equal to 1 divided by 1 over the first inductance plus 1 over the second inductance plus 1 over the third inductance. So we've got a lot of fractions here. In mathematics we call this a compound fraction, where you have a fraction inside a bigger fraction. As we put our values in here, we see that the total inductance is going to be 1 over 50 plus 1 over 200 plus 1 over 40. And I've actually shortened that just a minute. I need to remember as I enter these that all of these are millihenries. So make sure that we get the millis in there as we're entering it into the calculator. Now here's the tricky part. Remember the order of operations from way back when? Please excuse my dear Aunt Sally. Calculators know that order of operations, and so they're going to try to follow it. They're always going to do division, 1 over 50, before they do addition. What throws us off is the fact that all of this is in the denominator of the bigger fraction. And that's where we need to add an extra set of parentheses. If I will wrap this entire denominator up in parentheses, then that's going to help the calculator to come up with the right answer as I go through this. So anytime you have addition or subtraction, whether it's in the top of a fraction or in the bottom, you want to make sure that you get that whole thing wrapped up in parentheses whenever you put it into the calculator. So at this point it becomes fairly straightforward. Again, these calculators are wonderful because I can enter the problem exactly as I see it here. What I'm going to do is I'm going to say 1 divided by, open parentheses, 1 divided by 50 milli, so I need EE negative 3, plus 1 divided by 200 milli, which is EE negative 3, plus 1 divided by 40 millihenries, that's EE negative 3, close my parentheses, and hit enter. And when I do that, the result that it gives me is 20 with an exponent of negative 3, and that tells me that that result is also in millihenries. So your calculator is a wonderful tool. It's going to do a lot of the mathematics for you, going to do all the mathematics for you, as long as you remember to enter things accurately so that the calculator can interpret them the way that it needs to. Wrap things up in parentheses whenever they're under a radical, whenever it's in the numerator or the denominator of a fraction. Add a set of parentheses to make sure things are wrapped up and kept together the way that they need to. Then just use that EE key to enter your metric prefixes. Make sure that you're reading them out because your calculator is set in engineering mode and it's going to give you the answer with that metric prefix indicated.